Okay, today we're going to be talking about sky dome and celestial sphere. This is a way we can actually look at points in the sky, whether or not you're standing on the Earth, looking at your horizon and the part of the celestial sphere that's above you called the sky dome, half of the celestial sphere, or whether we're talking about sitting inside of the entire sphere, sitting on the Earth at any particular point, looking at straight up celestial equator, the ecliptic, which I'll talk about in a little bit, or positions above or below. If you're located right here, this line would be your horizon. You can see everything above it. If you're located right here, we'd have to draw a line right here. Everything you'd see here would be what you can see. Earth gets in the way of the other half of the sky dome. Okay, let's start with the actual sky dome. You're sitting in the middle of any particular point. There's a point directly above your head. This point is called the zenith. Let me pick a color here that will work. This is your zenith. And again, any place you're standing on the Earth, the point directly above your head is called the zenith. Point directly below your feet, called the nadir. And why that would make a point in the celestial sphere, because the Earth gets in the way, I'm not exactly sure, but it's 180 degrees away from your zenith. This over here is your horizon. Horizon is the point where basically the Earth touches the sky. If we were actually talking about here in Virginia, we would have these huge trees, whether they be evergreen or deciduous. We would have houses. We would have light poles. Everything would be covering our horizon. What we like to do is to actually talk about a perfect situation that wouldn't actually have any of that, and I do need to put that N back in there. This would be if you lived in big sky country like Montana. Not enough, maybe we'd have to worry about little bushes, but that again wouldn't cause much of a problem. It'd be nice here in Virginia to get rid of all the trees, all the houses, all the lights, all the gas stations, the McDonald's, golden arches, everything, so we can actually see the sky. I love seeing the sky, but the horizon is the point where the Earth touches the sky, separates the part that you can see from the part that you can't. Okay, next thing we have to do is we have to think about compass directions. The arrow here pointing to the north, that's actually signified by Polaris, which is also how we figure out our latitude. If you measure this angle from here in Virginia, this is about 39 degrees above the horizon, which gives us a latitude of about 39 degrees north. So this is our north compass direction. This is our south compass direction. Then if we're taking a look at it, this side over here is our west, and this side right here is our east compass direction. We talk about positioning in the sky. This would be 90 degrees up here. This location would be 0. This location would be 0. So if we go up, this is called altitude. Altitude, going from 0 up to 90. This is called right ascension. And sorry, that's not called right ascension. Right ascension is when we talk about the celestial sphere. This is called azimuth. And goes in a beautiful clockwise direction, where east now becomes 90 degrees, west becomes 180 degrees, south, west becomes 270 degrees, and north becomes 360 degrees. With those two, altitude showing you how far you go up, and azimuth, how far you go away from the north, you can find the location of celestial objects anywhere in the sky. Like that location would be 39 degrees up, and at 0 or 360 degrees azimuth, and that's the location of Polaris. or commonly called the North Star. Okay, any location on the celestial sphere, or in this case the sky dome, and this is actually called the sky dome, which I'm going to write a little bigger. This is the sky dome. Okay, so the sky dome is a location above your horizon. We can use altitude and azimuth to figure out the location of celestial objects. Celestial object is anything that's on there. If you do have a star like here, and a star like there, Betelgeuse and Rigel, with 3 stars, another star, another star. This would be the Orion constellation, sitting on the background, sort of here on the western sky. These would all be celestial objects. If they have a pattern, it's called a constellation. I think that's all we have to do with the actual sky dome. This down here, this is called the celestial sphere. Okay, this is the celestial sphere, and what the celestial sphere actually has is it has the Earth sitting in the middle. This is the Earth. It can also be shown by its symbol, circle with a cross, showing you the 4 materials that made up the Earth: earth, wind, fire, and water. This is the equator of the Earth. So if you actually stood on the equator, you let the Earth go from west to east in this direction. If you had a laser to point up, it would actually burn a hole all the way around the celestial sphere, and this is our celestial equator. If you watch my SFA video, we talk about the celestial equator being at 0 degrees, just like the Earth's equator being 0 degrees. We can go from 0 degrees up to 90 degrees. This is what's called the North Celestial Pole. Down here is the South Celestial Pole. If we draw a line from the south location, which we can literally put anywhere we want, through the North Celestial Pole, and sitting at the North Celestial Pole is that star, or really close to the North Celestial Pole, Polaris, showing you 90 degrees of what's called declination. And declination's moving from the celestial equator up toward the celestial pole, giving you 90 degrees. And then we also have, if this is the ecliptic, and the ecliptic is not drawn very well on this particular map, what I need to do is actually have this oval sitting up here. So if I actually did something that looked like this, that would be a better celestial equator. Where the celestial equator touches, the ecliptic, this is the ecliptic. This is the path that the sun takes moving across the sky. It actually hits right here, which would be our vernal equinox, and it goes up to the summer solstice, 3 months later down to the autumnal equinox, 3 months later down to the winter solstice. This point right there, that would be your vernal equinox. The vernal equinox, the entire planet experiences 12 hours of day and 12 hours of night. This is the summer solstice, which is actually 23.5 degrees above the celestial equator, equal to the tilt of the Earth. When the Earth actually tilts in toward the sun, puts the sun high up in the sky, warms our temperatures, gives us a higher If you look at my sun path video, sort of explains why we actually have warmer temperatures in the summer, colder in the winter, why it's warming up when the vernal, and where it's cooling down. This is the autumnal equinox, and this is the vernal equinox. Meridian actually divides the Earth. If I drew the sky dome looking south, this side's the north. If we drew a line from the south moving up to the zenith, and then coming back down through Polaris, and actually coming back down to the north, this is the meridian. If the sun were sitting on the meridian, I've done this on another video, this side of the celestial sphere is the AM side, which is anti-meridian, and this side going towards the west is the post-meridian. And if you abbreviate this, this is the AM part of the sky, this is the PM part of the sky. Do I need anything else in there? The ecliptic Polaris. If I drew myself standing right here, this point would be my zenith, and then directly below my feet over here would be my nadir, which just pops out 2 places on the celestial sphere, gives you another point for orientation or location. Okay, but right ascension, declination gives you like the latitude. Right ascension, vernal equinox, moving this direction would be 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, 7, 8, 9, 10, 11, 12 would be that far side, and then the other half would be this direction. Constellations move this way. They move, this is the east side, this is the west side. Sounds a bit strange, but remember, we're not looking down on a table at this map. We're actually looking up, and if you can imagine looking to the north, if you flip it up above your head, flip it behind you, then south is in front of you, west would be on this side, east would be on this side. But things rise in the east, celestial objects move towards the west, and then they move around so they can come up again the next day. Okay, I think that's about all I want to talk about today. Celestial sphere, sky dome, parts you can see at any one time. Parts you can see if you see everything. If you watch my SFA star chart video, it'll go more into locations of the celestial sphere in terms of declination, right ascension. I think this is the only time I actually talk about altitude and azimuth. Altitude, again, how far it is above the horizon, and azimuth, how far it is in a clockwise direction away from north. So you can be located right here, somewhere between 180 and 270, maybe 220 degrees of azimuth, and maybe 45 degrees of altitude, and that would be the location of an object that's right there. Remember, there are 88 constellations in the sky. Constellations are stars that take particular patterns of animals, people, objects, whatever. Okay, I hope you enjoyed the video. I'll be posting more later. Thank you.